All right, this is Mr. Wyrick. I'm going to go through this set of notes here with you for Friday, 131. So when we're looking at this, we're going to do volumes of prisms. We're going to do volumes of cylinders. When we're doing the volume of a prism, the volume is equal to the big B times H. That's the area of the base being multiplied by the height. If you have a rectangular prism, which is going to be most of, I think, what you're dealing with here, then that rectangular prism, it doesn't matter which one is the base. But if you do have a different shape, it's going to be important that you choose the unique shape as the base. You don't always want to pick the rectangle if you have triangles or pentagons or hexagons or something like that going up the side. When we look at this one, we find the volume of this one, the area of the base would be 10 times 3 is 30, and then 30 times 4 would be 120. So that's the volume of that prism. On this one here, there's some work that we kind of have to go through. We're going to use that unique shape to make the base. So this triangle is going to be what we're looking for. We've got a right triangle. We have base. We don't have the height here. So we go 15 squared minus 9 squared, but really, like I know ahead of time, this is a 3, 4, 5 right triangle. So this is 9. This is going to be 12 over here on this side. So 9 times 12, and then cut in half. Like I could multiply 9 times 12 and then divide by 2, but I can just take 12, divide by 2, that's 6. 9 times 6 is 54. So the area of the triangle is 54. I multiply by that by the 10 feet between them, and that's going to be 540 for the area of this triangular prism. If you get some other prisms, which the Delta Math I have assigned does have some other prisms, I believe it already has the area of the base for this one. It's still the same formula, area of the base times the height. So this is a hexagon, this is an octagon, but if they already give you the area of the hexagon or the octagon, again, you're just going to multiply that by the height. Okay. Then we've got the volume of cylinder. The volume of a cylinder is pi r squared times the height, which again, that's the area of the base times the height. It just so happens that that base is a circle. So we make sure we put that pi in there. If we have a radius of 3, that's going to be 3 squared is 9, so 9 times pi times 8. So this is going to be 72 pi. It does say round to the nearest tenth, but what I would type in the calculator is 72 pi, and then get my decimals from there. On the next one, it says a diameter of 10 feet. Be careful on that. Remember, diameter is all the way across the circle, and we just want the radius. We just want half of it. So half of 10 is going to be 5. 5 squared is 25. 25 times 3 is 75. So this would be 75 pi. Then this one here, I guess I will have to get the calculator on this one. Let's see. The first one is 14.5 for the diameter. So 14.5 divided by 2 is going to give me 7.25. I'm going to go 7.25 squared, because that's my radius squared. I got to multiply that by pi. Remember, you can just type pi in and then multiply that by my height, which my height is 18. And that gives me this, 2,972 point whatever. Then my other shape here, make sure I'm on the right spot, 22.8 and 18. So I take 22.8 divided by 2, that's going to give me 11.4. I take 11.4 squared, because that's my radius squared, and then I multiply that by pi, and then I multiply that by my height, which was 18, and I get this, 7,349.06. So I go 7349.06, because there was a different question here. Let's look at that question again. About how many times as much popcorn does the larger container hold? Okay, so it's asking how many times I'd have to multiply this small one to get to the big one. I'm going to divide this by 2,972.34. I just go 2 decimal places, almost 2.5 times more popcorn. Okay, or 1.5 times more. It holds 2.5 times the amount total. All right, so that's how that one's going to work. Your work today is going to be on Delta Math. There's I think I just finished this up, so let's take a look at it. Ah, yes, volume of prisms and cylinders. It's scheduled. It's not going to pop up until Friday. But if we go on it, didn't do the right thing here. If we go on there and look at the different skills, there's 4 different sections. The volume of rectangular prisms just either tells you about a rectangular prism. Yeah, it always just tells you. Sometimes it gives you a cube. Remember, that's just the same measure on every side. Volume of prisms is going to give you something like this. Sometimes it'll give you a head start and tell you this is the base area, this is the volume, what's the height. There's going to be different problem types there. So yeah, given the base area and the height, find the volume. Given the base area and the volume, find the height. Given the height and the volume, find the base area, or find the missing dimension. So not a big deal there. Volume of a cylinder is just a cylinder. Again, it's nearest 10th place. So make sure you're calculating that one with the correct formula. And then the volume of rectangular prisms or cylinders. Volume of a cylinder, volume of a cube. So yeah, this should be just fine. I think it's this one here, the volume of, yes, something like this. We have a pentagonal prism, but it tells you the area of the base. So all you'd have to do is take this and multiply it by the height in order to get the volume. So it's not anything complicated where you have to actually find the area of that pentagon just yet. Who knows if we'll get to that this year or not. All right, if you have any questions, make sure to save those for when I come back, and good luck.